All right, our final section in chapter 2. It's been a long chapter. We looked at solving equations, multi-step equations, distributing, identity, contradiction. We looked at rates, ratios, proportions, unit rates. We've looked at interest. We've looked at commission. Our last thing we're looking at, how the two things change, percent change. Now, the question always comes, when am I ever going to see this in real life? All the time. Whenever you see a sale, that's percent change. That's what we're looking at today. You see 25% off of all sweaters, or you see 30% off at Slumberland Furniture. Anytime you see a sale, you're looking at a percent change. It's always talking about percent off. Or you talk about markup. If you're a business owner and you buy something for a certain price, the only way to make a profit is if you mark that price up a certain amount. And that's typically done as a percent. So the percent markup. We have this formula. Percent change is equal to the amount of the increase or decrease. How much did it increase or decrease over the original? Because the original is 100%, and how much did it change is your part. Is what smaller part of 100% is that. So take a look at an example. From 8 to 10. So we want to know what's the percent change from 8 to 10. Well, if I use my formula, I don't know the percent change, P. The amount of increase or decrease from 8 to 10, how much did it change? Changed 2. From 8 to 10, it went up 2. So the amount of change, 2. The original amount, if it started at 8 and went to 10, the original amount was 8. Okay, I have an equation. What is P equals 2 over 8? Well, 2 over 8, that's 1/4, so P equals 0.25. Remember, that's not a percent. That's a decimal. That's a decimal. So to change a decimal to a percent, remember, if you think about the alphabet, from D to P, we're going to the right, and we're going to go to the right, to the right. That's a 25% what? Well, it went up. So from 8 to 10, I had a 25% increase. So what's the percent increase or decrease from 8 to 10? It's a 25% increase. Now be careful. From 8 to 10 is a 25% increase. From 10 to 8, you make up a different problem here. From 10 down to 8 is not a 25% decrease. From 10 down to 8, it goes down 2. The change is still 2, so P would equal 2. But the original would not be 8. The original would be 10. That, 2/10, that's the same as 20/100ths, and anything out of 100 is our percent. So it would be a 20% decrease. The reason I did that is to emphasize that it really matters which one is the original. Where did it start from? If it starts from 8, that's your denominator. So if it starts at 8, your denominator is 8. If you did it the other way around on accident, you said, well, it's from 8 to 10 is an increase of 2, and the original is 10. That's a very different question. That's this question over here. If the original was 10, we would have a very different answer, 20% decrease instead of a 25% increase. The original amount, where it starts from, makes a very big difference in your answer. So be careful about that. So this is how you set it up. How much did it change? What was the original? So I've got 3 here. Try this on your own. So find the percent change. Tell whether it is a percent increase or a decrease. So pause it, try it on your own. I'm going to assume that you paused it, you tried it on your own, and then now you're going to follow along with me and make sure that you did it the same way I did it. So the percent change, we don't know the percent. I know that from 75 down to 30, we're looking at a 45 change. It changed 45. Doesn't matter negatives or positives. How much did it change? It changed 45. The original was 75. Okay, so 45 over 75. 45 divided by 75, I get 0.6. So P equals 0.6, which if I change that to a percent, to the right, 60%. Now, did it go up or down? From 75 to 30, it went down. So it's a 60% decrease. So if you had a 60% off sale, everything's 60% off, everything must go. A $75 item, $75, I don't know, jeans, $75 pair of jeans, expensive pair of jeans, but $75 pair of jeans would only cost you $30 because it's a 60% off sale. So 60% decrease would take it from 75 down to 30. From 200 to 110. Now I'm going to set up a little bit differently for this one, actually, just for fun. Let's see what happens. I'm going to set up as a proportion. I don't know the percent, but I know percents are always out of 100. So instead of making it into a decimal, P equals 0.6, I'm going to make my percent into a fraction, because we're going to have to change them either to a decimal or a fraction. The original is 200. How much did it change from 200 down to 110? Well, it changed 90. I can solve a proportion. So 90 times 100, I'm going to cross multiply and divide 90 times 100. I'm going to get 90,000, or excuse me, 90,000, 9,000 equals 200p. Divide both sides by 200. And again, if you did it with an equation, don't change anything because you certainly could have done it correctly. There's more than one way to do these problems. You're going to have a 45%. I went from 200 down to 110. That is also a decrease. So if you did it with the equation, the same way I've been doing them so far, if you did it like this, P equals, and you did 90 over 200, and you divided and got a decimal, you should have got 0.45. And then you changed it to a percent and got 45% decrease. But you can do it in both ways, either as an equation with a decimal or as a proportion, where the percent is a fraction. Last one, again, you could have done it either way, and I'll do it both, just for fun. So we've got our original was 30. It changed 5. From 25 to 30, it changed 5. You could set it up as a proportion. You could set it up as an equation. It does not matter. Oops, excuse me. The original was not 30. Sorry, the original was 25. Need to change that. Again, get a very different answer if you do it wrong. There we go. So if I cross multiply and divide with my proportion, I got 500 equals 25p. And if I divide both sides by 25, I get 500 divided by 25. We're looking at 20%. And that would be from 25 to 30. That's an increase. And let's see if I get the same result when I divide here. 5/25 is 1/5, which is 0.2. Again, if I am changing a decimal to a percent, I go to the right, a 20% increase. It does not matter how you get there as long as you show your work. Communicate to me how you got that answer. Did you set it up the way on the left? Did you set it up the way on the right? How did you get to that final result? Which either one will give you the right answer. Okay, same formula, but we're given different information. It says find the result. Find the result when 12 is increased by 50%. Now we know the percent change. The percent change is 50%. So 50%, I can set that up 50 out of 100, because a percent is out of 100. The amount of increase or decrease. We know that find the result when 12 is increased. We don't know how much it changed. We know that it started at 12. Find the result when 12 is increased by 50%, but we don't know how much it changed. We do know that it started with 12. Okay, let's cross multiply and divide. 50 times 12 is going to give me 600 equals 100x. Divide both sides by 100 to get x by itself. Now, that's not my final answer. That's how much it changed. Remember, x tells us the amount of increase or decrease. How much did it change? I solved for x. I know that it increased 6. The amount of increase or decrease was 6. If it started at 12 and it increased by 6, the result will be 18. And that's my final answer, 18. Not 18 increased, not 18 decreased. That's the result. When I take 12 and I increase it by 50%, I get a result of 18. So get another one. Find the result when 55 is decreased by 60%. Same idea. If you want to pause it and try it on your own, feel free. I'm going to set this one up as an equation. So find the percent change. We know how much it changed. It changed 60%. I'm going to write 60% as a decimal. So I get 0.6 equals, I don't know how much it's changing exactly, so that's my variable, and I know it started at 55. I'm going to solve for n. Opposite of divide is times, so I multiply both sides times 55. 55 divided by 55 is just 1n left over, and 55 times 0.6, I'm going to get 33. But remember, that's the amount it changed. So if I started with 55 and I decreased by 33, what's the result? Well, the result is 22. So the two ways that this formula can be used, if we know what it's starting from and we know where it's ending, we can figure out the percent that it changed. If we know how much it's going to if we know the percent change, if we know what the percent change is going to be, and we know what it's starting from, we can figure out the result in the end. So a 60% off sale, if it was originally a $55 sweatshirt and you wanted to buy it for 60% off, what would the new price be? Be $22. All right, try these two on your own, and then I'll work through these last two. I'm going to assume you paused it, and I want to hurry up here so I don't have too long of a video. Find the result when 72 is increased by 25%. Again, we can set it up in a couple different ways. I'm going to choose the equation for this one. I'm going to make it into a decimal, 0.25 equals. I know the original was 72. I don't know how much it changed. So I'm going to multiply both sides by 72 to get n by itself. And if I take 72 times a quarter, I get that it changed 18 and it increased. So 72 plus my change, and I'm going to get 90. Second ones, again, please try it on your own first and then follow along and make sure that you did it correctly. I'll set this one up as a proportion just to show both ways. So I can set up my percent as a fraction. The original was 10. I don't know how much it's changing. So I can cross multiply and I get 400 equals 100n. If I divide both sides by 100 to get n by itself, I get that 4 equals n. But again, that's not my final answer. I want to find the result when 10 is decreased by 4. So the original minus how much it's changing, I'm going to get the result of 6. Try these 5 on your own. Come to school ready to ask questions, ready with problems. I didn't get how to do this, but please, please, please do these problems and be ready to ask questions on them in class.